All right, this is Mrs. Young, and we are now talking about the rules of naming compounds, and that is commonly known as nomenclature. Nomenclature is just a fancy word of how to name something. So we're going to be talking about ionic covalent compounds, how we name those compounds, and molecules. All right, so we've got two different types of bonds that we've been talking about, ionic and covalent. So make sure that you are writing that down in your notes. Covalent, you should be able to list three or more characteristics of covalent bonds. So make sure you know about 3 or 4 characteristics. Covalent bonds, remember this is a sharing of the electrons, not a give or take. A give or take of electrons be ionic. So because of this, the way that the electrons are shared or taken, you're going to name these compounds different ways. Another thing that you could say about your covalent bond is that covalent only occurs between your nonmetals. So 2 or more nonmetals, that would be a covalent bond. So remember nonmetals, things like oxygen, nitrogen, phosphorus, fluorine, chlorine. So if you see those metals, or if you see those nonmetals, then you know that is a covalent bond. Okay, ionic, that's going to be your metals, okay, or at least containing one metal. Now, those metals can be found in groups 1, 2, the transition metals that we talked about on your periodic table. Okay, the big block that take up about 80% of the entire periodic table. Okay, so if it has just at least one metal, you know that's going to be ionic. Okay, there's another type of bond, metallic bonds, but we're not going to spend too much time on that. You'll just name those the metal that they are. All right, so general rules of naming. Okay, these are the most important things. First, a cation. Remember, cation, what charge is that, positive or negative? Well, you know, a cation is positive because cats have paws. Okay, a cation is positive. So +1, +2, +3, +4, those are your cations, and those are always going to be written first. Okay, so you just state the element's name. Now an anion, right here, anion is going to be written second. Now if you have a positive with the cation, an anion should be what charge? It should be negative. And the only way that you change this anion is by adding an IDE. So chlorine becomes chloride. Oxygen becomes oxide. Okay. Carbon becomes carbide. Sulfur becomes sulfide. Now remember, on your periodic table, we've written down the charges. Go on your periodic table and look at the charges. If it is negative, if it has a negative by it, it's an anion. So above chlorine, you should have -1. Above fluorine, you should have -1. So fluorine becomes fluoride. All right, the only exception is going to be when there's a polyatomic ion that is involved. Now, this is in your notes packet. Okay, the polyatomic ions, you have a list of the very common ones. The polyatomic ion is going to keep their name at all times. Okay, so phosphate is always going to be phosphate. It's not going to change its name. So PO4 3 negative, phosphate. Okay, if that is in a compound, okay, the name is not going to change. We'll take a closer look at these in a little bit. All right, so here are 4 rules of naming. Rule 1, just name it. Rule 2, we've got Roman numerals. Rule 3, there's prefixes involved. And then the last rule, which we won't spend much time on, that's how we name acids. Okay, depending upon what chemistry teacher or any other teacher that you have for science, they may outline these rules in a little bit different ways, but this is the easiest way that I've found to name compounds, so that's why I'm going with them, because they're the easiest. All right, so let's start with rule 1. Okay, you should be writing these down in your notes packet. It follows along in the correct part, so find the nomenclature rules, and you should be writing this down. All right, rule 1, just name it. So like the rule 1 says, That's what you're going to do. When you see a compound that falls under these characteristics, what do? You just name it. So let's figure out which elements fall into this compound. Okay, if the first element is a metal, okay, so it has to be a metal. So it's in groups 1, 2, or 13. Okay, it's going to be a metal. 1 and 2, okay, those are the alkaline metals, or group 13. Now that is the group that starts with boron. It's right after the transition metals. So notice this is not anything to do with transition metals. Groups 1, 2, or 13. So does aluminum fall in this rule? Yes, it does because it's in group 13. All right, so just simply name the elements. Okay, both elements that are in there, you're going to name. So you don't have to worry about anything with the charge. Okay, so here's two examples. Ca3N2. So what elements make up that? Well, you've got calcium and nitrogen. Calcium, that's the cation ion, positive, and nitrogen is the anion. Now, what did we say in the general naming rules, what you do with the anion? You change the ending to IDE. So calcium, just name it. Calcium. What do? Nitrogen becomes nitride. So calcium nitride. All right, let's look at another one. Al2O3, a very common compound that you will see. Al is in group 13, so yes, we just name it. So just what element is that? It's aluminum. Okay, no fancy name. Oxygen, remember that is our anion, so oxygen becomes oxide. Just name it, aluminum oxide. Calcium nitride. All right, moving on. All right, so this is going to be our second rule. Okay, so our first rule was just name it. Our second rule deals with Roman numerals. Okay, so if the first element is a metal, okay, very similar to the first rule, but this time the metal is going to be in groups 3 through 12, 14 through 16. Now, a majority of this rule is going to be spent in 3 through 12, which you know more commonly as the transition metals. Make sure you're using your colored periodic table because that's really going to help you. Okay, so if this has a metal in it, is this ionic or covalent? Well, you should be thinking that it is ionic. Okay, rule 1 and 2 are both ionic bonds. I'd jot that down in the margin of your notes, okay? All right, the charge on these atoms vary. Okay, so if you notice when we wrote on our periodic table, we did not put any charges above the transition metals because they change, okay? The only exception is silver. It's always going to be a +1, but you don't have to memorize that. Just follow these rules and you'll be good. All right, the charge must be specified by including a Roman numeral in parentheses. Okay, parentheses. Okay, you may decide to remember this rule by parentheses. I think that would be a good and safe bet. So we've got two things. You've got silver and chlorine, manganese, and sulfur. Well, you're still going to name them the same way. So just name what elements they are. We've got silver and chlorine. Chlorine becomes chloride. Okay. Sulfur becomes sulfide. Okay, that should not be difficult. Okay, but let's take a look at how we are going to figure out what in the world is going on with the charges here. How do we figure out the Roman numerals? Okay, so remember, we've got chlorine. Okay, look above your periodic table. Make sure you have that periodic table out. What is the charge underneath or above chlorine? Right, it should be -1, right? -1. All right, well, look at silver and chlorine. How many chlorines are there? Well, there's just one. What's -1 times 1? Well, it's 1. So in order to get this to be a neutral atom, or a neutral compound, I'm sorry, what cancels out with +1? I just told you the answer. What cancels out with a -1? A +1, absolutely. All right, so how many silvers are there? There's only one, so what goes in the parentheses is a Roman numeral 1. Okay, I'm sorry that might be a little bit difficult for you to see me writing that. All right, let's go to this second one, sulfide. Okay, well remember that was sulfur. Look on your periodic table, what is above sulfur? Okay, that should be a -2, good. All right, there's no subscripts here that we have to deal with, so what cancels out a -2? Yeah, a +2. All right, so what goes into the parentheses? A Roman numeral 2. Now you've got a list of the Roman numerals because if you're like me, okay, you probably don't have every single Roman numeral memorized, okay, but really the only ones that you're going to need to know are 1, 2, 3, and 4. Occasionally you'll get a 5, but very rarely. Oops, thought I had a list for you. Okay, occasionally you'll get a 5, but very rarely. Okay, let's take a look at another one. Let me write this down. All right. All right, so hopefully you can see that it says Cu2O. Okay, if you can't see it, it says Cu2O. All right, so how would we name this? Okay, Cu2O. Okay, try to get that in your notes. You've got room in the margin. Cu2O. Take a second to do this. All right, so first things first. Is it a transition metal? That's what we want to know. Is it a transition metal? Yes. Which metal is it? It's copper. So we know it's going to be copper. It's going to have parentheses because it's a transition metal. And then oxygen becomes oxide. Remember that IDE ending. Okay, so how are we going to figure out what our charge is? How are we going to figure that out? All right, well, look on oxygen. Oxygen is what? -2. Okay, oxygen is -2. Well, how many coppers do we have? We have 2 of them, right? So oxygen is -2. What cancels out a -2? Okay, hopefully you said a +2. Is that what you said? +2? Okay, so this is where the tricky part comes. Okay, if we need an overall total charge of +2 and you have 2 copper atoms, okay, that +2 has to be spread out over 2 atoms. So what is the charge for each individual copper going to be? Hopefully you said +1. Okay, I know my writing is terrible, so apologize there. Okay, so basically, okay, you've got 2 coppers for every 1 oxygen. So you need 2 1 positives to cancel out that -2. So what goes into the parentheses? A 1 or a 2? Well, it's a 1 because your overall total charge on each copper is +1. Okay, I know that these are going to be a little bit tricky, okay, but we'll do some practice. Okay, we'll do some practice when it comes to the worksheets, okay? Just try to hang on to this one. Let's move on to rule 3. Okay, this is going to be your favorite one, okay, because it's the easiest. Okay, this is how you name covalent compounds. If the element is a nonmetal, the first element is a nonmetal, you only are going to use prefixes. Okay, you're only going to add prefixes. So if it's a nonmetal, okay, if it's oxygen, boron, okay, even some of these metalloids, okay, just add your prefixes. Don't think too much about it. Okay, know the prefixes. Mono, di, tri, those kinds of things. Okay, there's a list in your notes packet, and that's how you're going to name it. So CO, is that first element a nonmetal? Yes, it is. Okay, carbon. Carbon is not a metal. So how many carbons do we have here? One. Okay, remember subscripts you don't have to write. It's supposed to be assumed. So monocarbon, how many oxygens? There's only one. Monooxide. Okay, now you probably know that more commonly as carbon monoxide. Okay, so you can take off the mono on the first one, but not the mono on the second one. Just to be safe, just put mono on each one. Okay, let's look at the second one, P2O5. Again, this is in your notes, so you should be writing exactly what's on the board down. P2O5. Well, how many phosphoruses are there? There's two. What is the prefix for P? Or for two, I'm sorry. Di. Yeah, two. Di. So diphosphorus. And then how many oxygens? 5. What's the prefix for 5? Penta, like a pentagon. Okay, 5-sided shape. So pentaoxide. Remember, oxygen becomes oxide. All right, and here's a list. Okay, mono, di, tri, tetra, penta, hexa, hepta. Okay, probably not going to go over penta. Okay, there might be a few exceptions, but penta is really the largest that will go. All right, and then rule 4, this is our last one. Okay, this is our acids. Okay, the only time that you're going to have an acid is if the first element is an H. Okay, so if it's an H with any element, you're just going to say hydro and then fill in the blank here with an ic acid. So if it's hydrogen plus sulfur, it's going to be hydrosulfuric acid. Okay, if it's hydro with fluorine, hydrofluoric acid. If it's hydrogen with nitrogen, it could be hydronitric acid. Okay, so if any element, it's going to be hydro something. All right, if it's with a polyatomic ion, this is where polyatomics come into play a lot of times. Okay, if it's hydrogen with a polyatomic ion, if that polyatomic ends with the letters ATE, 8, you're going to replace it with an ic. If that polyatomic ion ends with ite, ITE, you replace the ending with an OUS. Okay, so for example, H2SO4. Okay, SO4 is sulfate, right? So sulfate becomes sulfuric acid. NO2. NO2 is nitrite. So nitrite, you replace it with an us, OUS. Okay, my chemistry teacher when I was in high school, she just kind of made adic itis. Okay, like if you have an ailment, you have some kind of itis. I don't know. That just made sense to me, and I never forgot it. So us. If you can remember us, then you don't have to worry about remembering adic. Okay. Notice I did not put hydro in front of anything with a polyatomic ion. Okay, that's going to be how you're going to differentiate between those. Okay, so if it has an H, it's going to be an acid. All right. So please review all of these. You can watch this video as many times as you need. Okay, go back to your general naming rules. Okay, if you need any of these again, okay, just keep looking over them. You got to keep practicing. There's a lot of things in your, there's going to be a lot of examples in your packet that you're going to need to do. Those of you who understand this and get it, especially the Roman numerals, okay, please help out your neighbor. I know some of you are going to pick up on this a little bit quicker, and that's great. But please help out your neighbor, okay? Again, these first two, ionic bonds, because they deal with metals. Prefixes, that's going to be how you name covalent bonds. Okay, and then acids, those are going to be a kind of a mixture, just kind of depends on what that acid is bound with. So don't worry about determining if the acid is ionic or covalent. Okay, if you got any questions, I really suggest that you just search YouTube for some naming, how you name elements and compounds. There's a lot of great videos online for you to look at. But try to understand this because a lot of your test is going to say, how do you name this compound? Okay, well, you got to know, is it a covalent or ionic bond? All right.